I'm Beth Lomax. I'm a research fellow at ESA now, and I did an experiment called REXUS that was flown on 2 parabolic flight campaigns. So the main goal of our experiment was to understand how electrolysis processes might be less efficient on the Moon or Mars. So when an electrode is in an altered gravity environment or a low gravity environment, the bubbles will stick to the surface more, and that kind of lowers the efficiency, lowers the surface area. And so we did an experiment to look at the removal of those bubbles in various gravities. So when I was a student, I decided to participate because really it was a kind of once-in-a-lifetime experience to be able to get this hands-on experience with a altered gravity platform. To be able to go on a parabolic flight was really amazing. And because the experiment was really related to my PhD work, I thought it was kind of a unique opportunity to get some experimental work done that would really make the project kind of stand out and contribute some really unique data to the work. Participating in the Parabolic flight campaign, I think, was extremely valuable for my career afterwards. It gave me this kind of hands-on experience with how to design and build and test hardware, which is really, really relevant if you're then doing any kind of work supporting technology development activities, as I do now at ESA. I also think the work that I did really strengthened my PhD, and that just really helped when I was applying for jobs after my PhD. Working on this project, I really learned a lot about the kind of different stages of a project and how to manage the project throughout all of those various stages, the kind of designing, testing individual components, putting it all together, testing it as a whole, actually implementing it. And I think that was extremely useful and valuable skills to get. I also really gained a lot of understanding about how to juggle science requirements and engineering requirements, like generating your science goals at the beginning of the experiment and then understanding which ones are critical, which ones maybe are nice to have, and then figuring out when you're going through the kind of engineering and design development process, how you can meet those or where compromise might be okay, where it's not okay. That's really, really valuable experience. I think one of the coolest things about participating in this project was the hands-on skills that I gained. Coming from the science background, I didn't have experience, building things, soldering, wiring, doing all of the things that you have to do when you build a piece of equipment like this. So I gained a lot of experience there as well. One of the most important lessons that I got from this project was kind of how to manage a project, managing a team of people, figuring out who's going to be responsible for which components, managing finances. There's a huge amount of procurement that has to be done to get a project like this going. How to manage timelines and meet really stringent deadlines. So it was all extremely valuable for all future projects. So one unexpected thing that we had during our experiment on the parabolic flight was just that some liquid went into a strange place during microgravity that we didn't expect it to. And it gave some really interesting, strange data. And when we looked more deeply into this, we realized what had happened, and it was a kind of false data from this liquid being in the wrong place. But it's that kind of thing that it's really hard to test for that in a lab environment because you can't test for microgravity situations. But just being aware that things like that might happen, designing your experiment accordingly, and digging into data that doesn't make sense, because usually if something doesn't seem like it makes sense, it's because it doesn't make sense. And yeah, I think that kind of experience, even though on paper you understand exactly what altered gravity does, having that kind of hands-on experience, seeing it yourself, seeing the bizarre things that might happen, is really valuable if you're ever in the future then developing hardware for altered gravity environments. think the biggest challenge that we faced as a team was relating to time management leading up to the flight. We were in kind of a unique situation doing it in the midst of the 2020 pandemic situation. But I think this applies to all teams. We just didn't do enough testing before our flight campaign. We just didn't have the time. It was such a shortened time schedule. And that led to just a lot of last minute changes or things we had to overcome or things that we had to fix on the fly. And it would just have been a much less stressful situation if we had done a lot of pre-testing and a huge experiment campaign prior to the flights. The other thing that we didn't get was the on-site visit, which I think, again, is kind of a unique situation, but any team could find themselves in that situation if their experiment wasn't ready in time. And if we'd had that on-site visit from the novice bus engineers before the flight, I think we would have identified a lot of small things that came up just within that last week, and it would have really, really helped us develop the experiment and have it ready to go when we arrived on site. So if you're developing the experiment, make sure it's ready in time for all that pre-testing and the pre-checks with the engineers. Another challenge that we faced as a team is that we were split across 2 universities, 2 different cities. Actually, in the end, when we did the experiment, because I was on a placement somewhere else, we were in 3 different locations as a 4-person team. And it introduced a lot of challenges that would have been a lot easier if we were in the same place and we could actually just all hands-on work together at all times. Logistics, timing. There's a lot of flying around. I think if you can figure out a way of making a team composition that limits those challenges, it would be really helpful. I think the best part of the project was actually during the development phase, like the many nights and weekends spent tinkering with the team at the time maybe wasn't amazing, but looking back on it, that was actually a really unique and fun experience. Obviously, the flight itself was amazing. Being able to experience microgravity is quite special. But I think whatever platform your experiment is on, just being able to see something come together and work after months and months of work is really, really validating and a really good experience. And obviously then being able to get useful data from it, maybe publish it or use it in a thesis is amazing. So I think in terms of advice that I would give to teams who are thinking of applying, the first one would be, it's an amazing experience. Absolutely do it, but be completely aware of what you're getting yourself into. It's a huge time commitment. It's not something you can do on the side. Also, make sure when you're developing the experiment that you keep it simple. The more complicated it is, the more places there are for things to go wrong. Particularly if you're talking about like operations during the experiment time, like in our case, during the microgravity time, we just pressed one button and then the experiment did its own thing, and we monitored it, of course, but it meant we could enjoy that and there was far less chance for things to go wrong in the moment. Just really keep it simple. And the final piece of advice I would have is when coming up with your research proposal, like really try and be very clear about what question you're actually trying to answer. What is the knowledge gap that your experiment can fill, and how will your experiment and that information you generate be useful to the field, not just to your independent experiment? So really find out where your idea kind of slots into the bigger picture. One thing that really helped me when I was preparing the proposal is that I spoke to a few people who were experts in the fields and also experts in proposal writing, and they gave me some really good advice about how to get the message across and to really, don't be afraid to use bold text, bullet points, lists, be very clear about exactly what you're trying to achieve so there's no ambiguity to the reader. And I think all of that advice was very useful. So don't be afraid to just ask people who know about these things and know how to generate a good proposal.
My name is Jaroslav Hruby, and I'm team leader of Project Oscar Cube, and also I'm currently working as a postdoc at Hasselt University in Belgium. The objective of the Oscar Cube experiment was to measure and map the magnetic field of the Earth from low Earth orbit. For this, we developed the novel type of magnetic field sensor, which is based on diamond and quantum operating principles. How it works is that we have a diamond in center of our device, on which we shine green laser light, which in turn gives us red signal. Then we apply microwave field to the diamond, and then we observe the changes in the red light intensity. From this, we can measure the magnetic field. In 2015, we were visiting Esrange in the north of Sweden, and we learned about the existence of the REXUS BEXUS program. We submitted there our first Oscar proposal, we got selected, then we flown once again on this platform, which actually gave us the confidence to go further to more complex platform. And then, when ESA Education released the call for proposals for the IceCubes platform on board the ISS, we went for it. I believe that participating in the Petri educational programs was very helpful from both team perspective and my personal perspective. Regarding the team, we started as a team of bachelor students, and nowadays the team grown to being PhDs, landed very nice jobs. We even have 2 people that were selected as a young graduate trainee of ESA. And on my personal side, I actually moved from being PhD student into postdoc researcher at the Hasselt University. For me, as a team leader, I had to learn quite some skills, especially in terms of communication and to developing the model of communication within the team, because we are a very interdisciplinary team, and it requires you to learn to speak each other language. Of course, we are all speaking English, but sometimes if physicist talks to electronics engineer or to software engineer, then they not always understand each other. So for me as a team leader, it was my task to actually facilitate this understanding in between different team members. But while doing so, I also learned many of technical skills, because within this facilitation, I also had to oversee the system development and to make sure that we are going all the same direction. The most valuable lesson I learned within the project is that one should never assume anything. If you are assuming something, just ask that person once again. Because if you assume, it means that you don't really know. So it's better to ask once again. When we got selected for this project, I had a vision that I would like every single student participating in this project to experience the entire life cycle of a space project, which meant that we need to make it within 1 year. And despite the vision was there, I was never truly believing it that we will manage, but at the end, we actually did. So that was the most unexpected thing that happened. The best part of participation in this program was the team and was the journey that we all went together. And the best thing is that even now, year after successfully finishing, the device is successfully returned back to the Earth, we are still sticking together and still pursuing next challenges. What I would like to tell to the next students who are considering applying to the ESA education programs, just go for it, because you learn the most by doing. And if you ask anyone in my team, they learned within these programs more practical knowledge than they could learn at university. So it's definitely worth it. And also this was massive boost for their career.
My name is Miguel Ferreira. I work at Space Application Services as a biosciences space business developer with the IceCube service. And I've conducted 2 experiments with the ESA Academy program. Both of them were focused on looking at how cells behave in hypergravity using the large diameter centrifuge. The first one was focused on angiogenesis, which is the process of formation of blood vessels. And the second one was focused on tendon cells. With angiogravity, we were looking at the formation of blood vessels in hypergravity. And to do that, we used endothelial cells, which are the cells that make up the inner lining of the blood vessels. And we grew them on a very soft hydrogel that is a material that allows cells to form capillary-like structures that look like blood vessels. And what we were trying to understand is how hypergravity can affect this process. So to do that, we compared cells that were grown inside of the large diameter centrifuge in hypergravity conditions to cells that were grown outside of the centrifuge in normal gravity that we experience on Earth. And we really compared these two and looked at how the cells can assemble into these structures. And this can give us information about the process of angiogenesis. And this can also have implications in the field of tissue engineering and cancer therapies and many other health conditions that blood vessels are important for. When I started university, I got quite interested in the field of space biology and really understanding how gravity and other forces would impact cells and tissue formation. And we found out about this program on the ESA website and just decided to apply. And we thought it would be a really good opportunity to start getting some research experience and also getting into the space field. So we just did that and it ended up going really well. The participation in the program was really important for my career. So before participating in the program, I was a university student and I had no experience in research whatsoever. By participating in the program, I learned not only hard skills, like lab type of skills, but also got contacts and learned other types of soft skills that were important in all my career progression. So after participating in this program, I went on to do my PhD in regenerative medicine. And learning how to plan an experiment was really important to then do my own research project. Now I'm working with the IceCube service, and what I do is help other researchers send experiments to the International Space Station. So I'm really making the bridge between the space world and the non-space world, which was something that I kind of went through myself. Because before participating in the program, I was a student that had no research experience and no experience in space. And now this really helped me understand how to talk to both, for example, ESA and other professionals in the space industry, and then also researchers that have never heard of space. And I think it's really been important for me to be able to make that connection. I think the most important lesson I've learned through the participation in this program is really to keep things simple. Because when you're doing research and planning experiments, it's very easy to get distracted by very interesting things that are interesting, but maybe they're not fundamental to answering your research questions. And by participating in a program in which you had to do a particular specific experiment in a well-defined time frame, in a specific place that you could only access for a short period of time, really makes you start thinking about the priorities of what you really want to achieve. And in my experience, keeping it simple is really important because otherwise you may end up not getting the answers you really need. There were many unexpected things. There were unexpected results and also unexpected things that happened along the way. One of the things that was the most unexpected had to do mostly with our second participation in the program. So we were participating in this program while finishing our master thesis, and the deadline for submission of our thesis was exactly in the middle of the campaign week. So it was quite challenging because we were finishing up writing while also doing the final experiments and the campaign for the program. And that was very unexpected. In our project, we were looking at the formation of blood vessels, and initially we thought that hypergravity would stimulate the cells to grow faster and to form bigger and stronger blood vessels. And what we saw was exactly the opposite. So we saw that by spinning them in the centrifuge, we actually saw a decreased formation of capillary-like structures. So this suggests that blood vessel formation was decreased instead of increased. So this was very unexpected. I think the biggest challenge had to do with managing a whole project that had to be executed with almost no room for failure in a very specific time frame. So we were young students with almost no experience in research. We didn't really know how to plan a project before doing this program. And we ended up having to do it in another country, in a collaboration with different labs. And for example, shipping all the reagents, all the cells, all the samples from one country to the other was something that had to be organized, and we really had to do that. And it was quite challenging in the beginning, but then it was something that through proper planning and a lot of organization we could achieve. And even small things that sometimes you don't really think about when you're doing your research on your lab, they become really critical when you can't really have room to repeat experiments many times. So when we were here in the first time we did spin your thesis, we had our cells that were in culture in the lab, and we had a contamination. So we had to get rid of all the cells and get new ones out. So really thinking about having a backup plan is really important. And luckily we had other vials of cells that we could use. But if we wouldn't have it, then it would have been really critical for the experiment. The best part of this program is really to have the chance to do a project from start to finish and to really experience the dynamic, multicultural, multidisciplinary work environment that exists here, but also bringing in a team from a different lab, coming to ISA ESTEC, doing the experiment with all the experts from all around the world, and doing your own experiment in your lab with the team that you choose was really fantastic. And then these are also people that I'm still in contact with, and that we're really continuing throughout my life as a part of my life, and also in both in work and personal aspects. The biggest advice I would give, if someone is thinking about participating, is really to apply and to go for it, because at least in my case, I thought that by being a young student, I really didn't have the skills or didn't have the expertise to do it. But that's also why these programs exist. So the idea is really to get students to apply, and then during these educational programs, the students will learn how to do the experiments. So it may seem that space and ultragravity research is something very distant, but actually it's not. And it can easily be reached through the participation in these programs and also through other opportunities that exist. And I don't think people should be afraid of doing it. They should just take the initiative and apply.
I'm Esmée. I'm a student at the Technical University of Delft. I'm graduating soon, and next to my studies, I am a part-time employee of T-Minus Engineering, which is a sounding rocket company. And I participated in the REXUS project. So we flew an experiment on REXUS 28, and I was the team leader of the SPEAR mission, which is the supersonic parachute experiment aboard REXUS. With the SPEAR mission, we aim to flight test our Hemisflow ribbon parachute at supersonic velocities. And the vehicle consisted of an ejectable test vehicle that would then descend throughout the atmosphere after its REXUS separation. And then when it picked up enough velocity, enough speed, it would deploy our drogue parachute and have its test experiment. Then later on, we would deploy main parachutes to slow down the vehicle and recover it and collect all our data. So for our team, it was that I was part of a recovery team, and we really wanted to test this parachute, and it's very hard to test a parachute in supersonic conditions. So REXUS was this great flight test opportunity for us, and the program itself and the educational experience was more of a bonus later on. But we were very happy to participate anyway and have our flight test possibility. So I actually accidentally got into the student rocketry in a very odd way, but then when I got in and did my first rocket launch, I was completely hooked. And I thought recovery was very interesting because it's very diverse. You're doing parachute work, aerodynamics, but also material science and also a bit of, let's say, energetic materials in our deployment systems. And then for the REXUS program, I thought it would be really great to actually test this parachute that I had been working on for a few years already. And that's why I really wanted to join on this mission as well. I think the biggest thing where it helps your career to participate in a program as such is that you gain so much experience besides your studies, so on a more practical level, to actually complete a project from conception to design, testing, and finishing it and flying it is an experience that you also don't even really get in your career that often. So it's a very unique way of going through the full cycle and seeing it all and doing it all yourself. So I think there were two things that I developed. First of all, I was the team leader of this project, and it was the first time that I was doing that for such a complex mission. So that's something I really learned throughout the whole process. And in being as a team leader, I really learned to give feedback to my team members, positive and negative. That's difficult to balance. So I really gained some experience there. And then also I learned composite manufacturing, because that was something that was not very present in our team. A lot of our members knew metal manufacturing, but we also had some composite parts that I mainly made. I think the most important lesson that I learned was that as a team leader, you have to know what is going on everywhere. So I was personally very inexperienced in electronics. I didn't know what it meant, how it worked, what we actually needed to do. But that was actually very challenging, because it did not allow me to keep tabs on what was happening, on if we were delayed or not. So that's something I learned, that you actually have to know a bit of everything, what's going on, what kind of tasks are still open, what kind of challenges can you face to be a good team leader and keep track of your project progress. So the unexpected thing in our project is that we had a really great time to also do outreach in our project and to talk at different conferences about our project. And what really surprised me in that is that the actual, let's say, engineering society, so professionals, were very interested in our mission, because there are very few supersonic parachute tests in flight in the whole wide world, that even the professionals were very interested in our mission on a serious level. So during the Spear mission, we actually had two large challenges. I would say the first one was during the startup and the design of our mission, where we actually were struggling to get sponsorship and find financial contributions to fund our mission. And in the end, one of our technical supervisors helped out with that to collect that, which was very nice. And then later on, we were struggling a lot with the volume allocated to us in the Spear mission, because even though we could make it fit mechanically wise, the cabling, so the electrical mechanical integration, was a challenge, but also the assembly procedures and the assembly itself. Sometimes, even if everything fit part-wise, you could not actually get a tool in a specific position to fasten it. So that really delivered some very tight assembly procedures that we had to try out a lot of times before we got it right. The best part of the participation for me, I think, actually were the testing weeks. I really enjoyed the vibration testing week and also the bench tests weeks, because you're there with, let's say, all of the teams in your rockets, and it's very focused also on the interaction between our mission and the other teams on the same rocket. So you work together with the other student teams as well, and I've found that very interesting. So the biggest recommendation that I would have for participating in the REXUS program is maybe to focus really on one mission and on one thing that you want to develop, because we in the end had quite a few subsystems that had to be developed from a low technical readiness level, as you could say, and that cost us a lot of time and made us run into timeline issues in the project. So try to really focus on one experimental feature, and everything else, either get it commercially off the shelf or take some parts that are already developed in your team and keep it as simple as possible.
My name is Dumitria Sandu, and currently I was given the unit functional leadership of a subsystem of the Ariane 6. Me, Federico, Giovan Battista, and Luca were a group of engineering students of the University of Padua, and we decided to participate to the REXUS BEXUS program. Given the goal of our project, we decided to use the BEXUS platform. So the idea coming from university lectures bring our attention to the effects of the atmospherical pollutants caused by human activities. So nowadays, the technology used to analyze the different pollutants in the air are remote satellite observation and ground-based technologies. The aim of our project was to fill the technological gap and trying to do a dynamic sampling of the air at different altitudes. To do that, we used prototype which was compact, inexpensive, and reusable. Therefore, it was composed by a pneumatic system, by electrical parts to have telemetry, and also every kind of data from atmospheric temperature, pressure, humidity, and so on. And also active and passive control of the temperatures given the really hard environment we can find up to 35 kilometers where our experiment arrived. Then after the sampling of the air using, as I said, the filters and sampling bag, we bring the samples to a laboratory to do chromatographic analysis of the samples. I was always fascinated by the ESA world, and as an aerospace engineer, I thought that is the place where our dreams come true. And it was really the case with this experiment, because I felt the need to put in practice my knowledge, and it was an opportunity I couldn't miss. I can say it helped a lot. Firstly, because I learned a lot of both technical and soft skills, but also because simply it is an curriculum-enriching experience. And I can say nowadays more and more companies are aware of the important skills that the students participating in this kind of program acquire by participating in ESA Academy programs. To speak truly, the list is pretty long. I could start from just the problem-solving skills that I trained a lot during the program, starting from the impossibility of using university facilities and ending with the problems we had during the launch campaign. We always needed to find alternative solutions, and that was possible also thanks to the teamwork, and I think it's the most cited soft skill that we can find in curricula, but in my opinion, it's really one of the most important, because it's really discovering our teammates, their inner abilities, was possible to solve every problem we found out during our experience. Coming back to the experiment, it was also the first time we had to write the requirements and the constraints of a project. So I remember the first list we gave to the ESA members, and I think there was any of the requirements we wrote was correct. But as with everything, we learned to do it properly, and also thanks to my experience as a test campaign manager, I can say, I really checked by myself how well we we done this list of the requirements. This experience also as a test organizer gave me the possibility to not only see in detail the behavior of each subsystem, but also the interaction between them and predict possible future problems that we were during the launch campaign. The biggest one, I think, was the one we had during the launch campaign. As the day before the launch, we discovered that we have communication issues with our experiment. So it was a software problem. We passed all the evening before the launch trying to fix the problem, even if we had a backup solution, as our device was semi-autonomous. It means that depending on the altitudes, it was able to change the phases of the sampling, but we wanted still to have the complete commandability of the project. So we tried and we fixed it, fortunately, at the end. In my opinion, the best part was the team working and also the opportunity to meet students from all over Europe, as well as having as mentors ISA members, and finally to test our experiment during a real launch campaign, to test a project that took us 2 years of work during our lectures, exams, and also, I don't know, internship, for example. At the end of the program, you see it will be easier for you to switch from theoretical prediction to real expected results, and also you'll be aware of the challenges that space environment bring to your future project. I can say that it will be also possible, seeing also the other teams, to create your own company. Why not? And so to start your own startup and bring this idea that you started as a student to an upper level. If you really want to experience a space-related adventure, this is for you. And remember that you can do it only as a student. There is no way back. So catch the opportunity.